Alright, let's get into the second part of tutorial 3. Okay, so we're on question 3, and we have to combine and simplify. Okay, the first one is already combined into a single fraction, so let's just multiply it and see what happens there. So at the top, or let's first write on the question. So the question is a plus b squared minus ab. And this is all over ab. Okay, so no fractions we have to add together or anything. So let's just multiply out the top. So if we square this bracket, remember that squaring the bracket means multiplying by itself, and that it does not mean, so this, what I'm showing here is wrong now, it does not mean you just do a squared plus b squared. That is not correct. So remember that. I often see that mistake, people making that mistake. Alright, so minus ab all over ab, and then we just multiply it out. So again, you can't just square the bracket directly by doing this all in your head, that's fine. So remember, we do this, everything in the first bracket multiplied with everything in the second bracket. So a squared plus ab, we do the same for b, so b times a is ab, and b squared. ab and b squared, oh, that a looks ugly, minus ab, all over ab, and finally we just collect our like terms. So a squared, so it's just the 1. Then the ab's, so ab plus ab is 2ab, minus ab is just 1ab, and then plus b squared. And that's all over ab. And nothing else we can factorize at the top, so that's it. That's our final answer. So that is combined into a single fraction and simplified. Alright, then question B. Question B. Okay, so here we have two fractions that we need to combine. So 2 over x minus 2 minus x over x plus 2. Okay, so we need a common denominator first. So a common denominator would be these two multiplied together. So we have the x minus 2 and the x plus 2. That's our denominator. Here we had a 2. So this fraction only has the x minus 2 part at the bottom, so it still needs the x plus 2 part. Then here we've got an x at the top. This fraction only has the x plus 2 part, so it still needs the x minus 2 part. Okay, and then we multiply out at the top, so 2x plus 4, and then minus x squared plus 2x. That's still over x minus 2 and x plus 2. And now we just collect our like terms. So the x squared is just the one term, that's negative x squared. The x's, the 2x plus 2x, which is 4x. And then we've got a plus 4 over x minus 2 and x plus 2. Okay, at the top, can we factorize this? 4? No, that cannot factorize any further. So that is our final answer. I suppose you could factorize a part of it. You can either take a common factor of 4 out of there, or you can take a common factor of x out of here, but that's not going to make it into a single term at the top, so that is fine. This will be your final answer. But just in case you wanted to check what that would look like, so one option is to take out, let's say even a negative x from the first part, from this, and that would then give us what's left is then x minus 4. And then we still have the plus 4 at the end, over x minus 2 and x plus 2. Okay, so this I think is less good than this. I think this should be the best answer, but you can also have this, or you could also have negative x squared and then take out a 4 as a common factor from these two and be left with x plus 1 over x minus 2 and x plus 2. So that would also be correct. I think all of these would be correct. I prefer this one that I circled here. I think that's the most logical place to stop. Okay, and then for question C. So here we have x squared minus 2x minus 3 over x squared minus 2x divided by, and then it's x squared minus x minus 6 over x cubed minus x squared. X cubed minus x squared. Okay, so again, let's factorize everything we can first. So this part here, this we can factorize as a quadratic trinomial. That's going to be x minus 3 and x plus 1. over, and then we factorize this part. Here we can take out an x as a common factor, and we're left with x minus 2 in the bracket. Here, I'm just going to do two steps in one here. I'm going to change the divide into a multiply, and then switch these two around. So this one goes to the top, and here we can take out an x squared, and what's left is x minus 1 over, and now this part we can factorize into x minus 3 and x plus 2. Okay, so now we've got a single term over a single term, so we can start cancelling some things. So the x minus 3 and the x minus 3 can cancel. This x can cancel with one of these x's. Then we've got, that's pretty much it, right? Nothing else can cancel. So what we're left with is at the top, we've got an x plus 1, and an x minus 1. And at the bottom, we've got an x minus 2 and an x plus 2. Okay, and that is a single term, so that is a proper answer there. Okay, good. So that was question 3, pretty straightforward. So you want to find a common denominator if you're adding or subtracting, so with plus or minus common denominator. When you're multiplying or dividing, much easier, just factorize everything. Even here, if there was something that could factorize in this question, you would factorize first. So you check each individual part, each numerator, each denominator, see if you can factorize, and if you can, then you do that. It makes your life a lot simpler. And if you have plus or minus, then we find a common denominator and do that work that we did over here. If we just have multiply or divide, we just start cancelling after we factorize. And that's it. Straightforward. Alright, question 4. Question 4, A. What are we told to do here? Using Pascal's triangle, determine the following. Okay, so that's to the power 7, to the power 8, to the power 12. Okay, so we need a big Pascal's triangle here. Let me do the Pascal's start here. So 1, 1, 1, 1, 2, 1. So again, what we do is we start with a 1, we add the next two terms, add the next two terms, and end with a 1. And you just keep going like this. Okay, so 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, and 1, 1, 8, 28. You see, this is not nearly far enough yet. We need to go all the way to the 12th one. So this is the zeroth row. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And we need to go all the way to the 12th one. Okay, so that's 28. Then we've got here 56, 70, 56, 28, 8, and 1. 1. So this is the 9th one. 1, 9, 36. Ooh, what is this? 20, 70, 84, 126, 126, 84, 36, 9, and 1. Now the 10th one, so just 3 more rows, 10, 11, and 12 to go. 1, 10, 45. This is 110 plus 10, 120. This is 210. 210. This is 200 and what is that? 252. Then 210. 120, 45, 10, and 1. Now the 11th one, second last one here. So 1, 11, 55, 165, 330. What is this? This is 462. This is again 462. Then 330. Then 165. 55, 11, and 1. And then the last one, row number 12. Okay, so 1, 12, 66, 220, 495, 7, what's it, 462. Okay, so that's going to be 792. 792. This will give us 900 and what is that? 924. Okay, then again 792, 495, 220, 66, 12, and 1. Okay, so there's a big long Pascal's triangle that we want to use. So for question A, we're told to use Pascal's triangle to determine the following expansions. Okay, so this is just long and tedious, nothing really too interesting going on here, except this triangle is pretty cool. And we'll see these same values repeating itself when we get to the next question, it looks like, but when we use the binomial theorem, because that yields the same values as Pascal's triangle. Okay, so for the first one, we've got 3 minus x to the power 7. Okay, so the seventh one, let's do specific colors for this. So for question A, we'll do the green one, just so we can see where we're working. So that is going to be this one, the 7th row. So those are the coefficients, right? And another thing to know, if we've got something like a plus b to the power, let's say 3, right? So we start off with 1. So for 3, let's do squared just to quickly show what's happening here. So for 2, so we're going to start off, we're going to have the second row, which is this one. So it's 1, 2, 1. So we're going to have 1, 2, 1. So our first coefficient is 1. So we don't have to write that, but just to show we have 1. Then we've got the first term, so this term here, to the power 2, so the maximum power. And then the b is to the power 0. So these two together must always add up to the total, the n here. So we start with the maximum for the first one and the minimum exponent 0 for the second one. Then plus, then our coefficient is 2, and then we've got the first term, we subtract 1 from this exponent. So instead of 2 we now have 1, and then the b, we add 1 to the exponent. So instead of 0 we now have 1, and again 1 plus 1 is 2, which is what we want there. Plus, and then our coefficient is again 1. Then for the a, the first value, we subtract 1 again from the exponent, so 1 minus 1 is 0. And then for b, we add 1 to the exponent again. So 1 plus 1 is 2. And that's it. But again, obviously we don't write it like this. We just usually write it, so 1, so b to the power 0 can cancel out, 1 can cancel out, so we just have a squared. Here, we've got 2ab, remember the plus, and then plus, then this can cancel out, that can cancel out, so we just have b squared. So that's the basic idea. Now let's apply that to our bit longer question with to the power 7. So we're going to use this 7th row. So these are our coefficients that we're going to use. So we're going to start with 1. And again, we don't need to write the 1. I'm just writing it down for the sake here. So 1. Then our first term to the power 7. And our second term, so negative x to the power 0. Right? Negative x to the power 0. And again, I'm not actually going to write this because anything to the power 0 is just 1. But we know there's actually a 0 there. Okay. Then next term is going to be the coefficient is 7. Let's do this so we know where we are. So plus 7. Then our first term, subtract 1 from the exponent, so that's going to be 6. Then our second term to the power 1, right? Okay, next we've got the 21 is our coefficient. So 21, then our first term, subtract 1 from the exponent, so 6 minus 1 is 5. Negative x, add 1 to the exponent, so 1 plus 1 is 2. And we just keep on repeating this pattern. So plus, next coefficient is 35. So 35, 3 to the power 4. Negative x to the power 3. Plus, next one is 35 again. So 35, 3 to the power 3. Negative x to the power 4. Plus, next one, 21 again. So 21, 3 to the power 2. Negative x to the power 5. Plus, then we've got a 7. So 7, 3 to the power 1, negative x to the power 6, and finally plus 1. Let's see, that can fit in the last line here. Let's just put that in. So plus, and our coefficient now is 1, 3 to the power 0, which is just 1, and then negative x to the power 7. Okay, and then probably want to simplify this. So I'm just going to let you simplify those numbers if you want to. So work out what 3 to the power 7 is, work out this whole value here, this whole value here, and you can simplify the rest from there. But the most important part here is getting this step right. From here it's pretty easy. You just, because there are no like terms to collect, that's why we use Pascal's triangle. All of the like terms are already collected here. We just have to simplify the numbers. And that's it. Make sure our signs are correct. So if you have negative x squared, obviously it's going to turn into a positive, because a negative times a negative is a positive, etc. Alright, so that is for question A, the first step, and I'm going to leave that there. Question B, so let's do that in, what color? Let's do that in blue. So for B, we've got 2x minus y to the power 8. Okay, so now we're going to use the 8th row. We're going to use the 8th row, this row here. Alright. So again, we've got our first term. So 2x to the power 8 plus, then we've got the 8 here. So plus 8 is our coefficient. So 8, first term to the power, subtract 1 from the exponent, and then times negative y, add 1 to the exponent. So that's now 1. Plus, next coefficient is 28. So plus 28, first term, we subtract 1 from the exponent again, so 7 minus 1 is 6, and then add 1 to the y's exponent, which is now going to be squared. And again, all the time you'll see, so 8 plus 0 is 8, 7 plus 1 is 8, 6 plus 2 is 8, so they'll always equal that. If you keep on adding 1 to the first term and subtracting 1 from the second term with the exponents, that is going to be the correct answer in the end. Okay, then we've got 56. So 56, first term to the power 5, second term to the power 3, plus, next one is 70. So plus 70, first term to the power 4, second term to the power 4, plus, now it's 56 again. So 56, first term to the power 3, second term to the power 5, plus 28. So 28 is our coefficient for this term. First term, subtract 1 from the exponent again, so that's squared. And then the second term, we add 1 to the exponent, so that's going to be 6. Plus 2 more terms, so 8 is now our coefficient here. Then we've got first term to the power 1, second term to the power 7, and finally we've got 1 times our first term to the power 0, which is also 1, and then our second term to the power 8. And again, the simplification from here, the rest is just making sure all your signs are correct and multiplying out the numbers. Okay, then question C. Let's do that in red. So for question C, we have to go all the way to the 12th power. Okay, so our question is, where's my pen? 2x to the power negative 1 minus 1 over 2 to the power y. Oh no, minus half y, sorry. It's just minus half y. Okay, all to the power 12. So that means we're using this row. So that's going to be a long boy. Alright, so let's write it out. Okay, we're probably going to use 2 lines for this. So again, we start off with our first term to the power 12. Plus, now our next coefficient is 12, so plus 12, first term to the power 11, and then second term to the power 1. So we don't have to write the 1 there. Plus, okay, next we have 66. So plus 66, first term to the power 10, so we keep on subtracting an exponent from the first term, and adding an exponent to the second term. So instead of 1, we now have 2. And again, 10 plus 2 is 12, so we know we're on the right track still. Plus, next coefficient, 220. 220, first term to the power 9, second term to the power 3, plus, next coefficient, 495. So 495, first term to the power 8, and second term to the power 4. Okay, plus, so let's go on the next line. Plus, next coefficient 792. So plus 792, first term to the power 7, and then the second term we're up to the power 5, plus next coefficient 924. Okay, first term to the power 6, second term to the power 4. 6 to the power 6, plus next coefficient 792 again. 792, first term to the power 5, second term to the power 7, plus next coefficient 495, plus 495, first term to the power 4, second term to the power 8, plus, okay, four more terms, sorry, plus 220, first term to the power, subtract 1 from 4, so that's going to be 3, and then second term to the power 9, plus next coefficient is 66, first term to the power 2, and then negative 1 over 2y to the power 10. Two more terms to go, so plus 12, 12, first term to the power 1, and then second term to the power 11, and finally plus 1 times the first term to the power 0, which is also 1, and then our second term to the power 12. Okay, so this is pretty much all this is, being able to write out this triangle and then just computing this. So if you try to do this without Pascal's triangle or without the binomial theorem, this would take you probably like a couple of months. If you just wrote this thing out 12 times, multiplied the two brackets together to get an answer, multiplied that answer with the next bracket, etc., and then collecting like terms, and the chances of making a mistake are even so great as well. So Pascal's triangle definitely does help to make life a little bit easier. Alright, but again, if you have any questions on why we're doing this, but I think this is pretty self-explanatory how this works. We did a couple of examples so you can see the pattern of the exponents and how we use the coefficients here. But again, let me know if you get stuck somewhere. Okay, last question for this tutorial. We are on question number 5. Compute the following. Okay, so the first question, they ask us to compute 3 times 11 choose 10 minus 2 times 6 choose 4. 6 choose 4. Okay, so how do we compute 11 choose 10? So for computing 11 choose 10, let me actually start with smaller numbers just to show what it works. Let's say we've got 3 and we have to choose 2. Let's start with a small number to show. Okay, so let's say our 3 things that we have are A, B, and C. Now we need to choose any 2 of these things. So how many different ways can we choose 2 things here? Well, one option is we can choose A and B, or we can choose A and C, or we can choose B and C, right? Those are the things we can choose. So the answer to this should be 3. So a couple of ways we can think about computing this. I think, let me do this one. Let's say your calculator has a button that looks like that on most calculators. So the N is the top one and the R is the bottom one here. So you can just type in your calculator 3, press this button, and then say 2, and that should give you 3, right, if we did this part correctly. So there are 3 ways we can choose 2 out of the 3 things. So that's basically what this means. Okay, another way we can think about this is that is also the same as saying 3 factorial divided by 2 factorial times 3 minus 2 factorial. So let's see if we compute this. So 3 factorial, factorial just means, like if we have, well, 3 factorial just means 3 times 2 times 1. 2 factorial means 2 times 1. 3 minus 2 is 1. So 1 factorial is just 1. Okay, so 1 factorial is just 1, so let's just rewrite this as 3 times 2 times 1 is, that's going to be 6. 2 times 1 is 2, and 1 factorial is just 1, and 6 divided by 2 is 3. So we see we get the same answer, right, as we got over here. So that is basically what this all means. Now how we got to this, a little bit more involved, and we don't need to worry too much about where this comes from. But suffice it to say, we can just use that on our calculator, or we can just use this function on our calculator. So using the factorials, or just using the built-in function. Okay, so basically, I mean, you can basically just type this in your calculator. So maybe you can try that. Just type 3, bracket, then you type 11, then you type the NCR button, and then 10, close bracket, minus 2, open bracket, 6, NCR button, 4, close bracket. So just type that in your calculator and see what answer you get. That should be the correct answer. But for this, let's compute it using the factorial thing. So we're going to have 3 times, and then we're going to have 11 factorial over 10 factorial times 11 minus 10 factorial, minus then 2 times 6 factorial over 4 factorial, and then 6 minus 4 factorial. So maybe let's just write down the formula here. So if we have n choose r, we can say that is n factorial over r factorial, and then n minus r factorial. Right, so this is what we're using. The fact that these two things are the same, we're using that to compute this. Okay. So here we've got 3 times. So 11 factorial. So 11 minus 10 is just 1, and 1 factorial is just 1, so that can cancel out. Now 11 factorial over 10 factorial is just 11. But again, you can, let me actually get a calculator out just to show that I'm hopefully not lying. So let's do 11 factorial divided by 10 factorial. That's just 11, right? Okay. Minus 2 times, and then 6 factorial over 4 factorial times this. Okay, so this one, let's do a bit more work here. So 6 factorial is going to be times 2, 3, 5 factorial is 120. I think it's 720, but let's make sure about that. So 6 factorial. Can I just type it like that? Yeah, 720, that's correct. Okay, 720. And then 4 factorial is 24. And 6 minus 4 is 2. 2 factorial is 2. Okay, so this gives us 33. Minus, and then the 2's can cancel out. That's quite nice. So minus 720 over 24. And that is 30. So that's going to give us 3. Okay, nice. So hopefully you also got 3 when you just typed it in your calculator. Let me see if I just type this whole thing. Let me actually do this. Let's go to Wolfram Alpha. Very nice website that we can use. So let's do NCR. Does that give us the right thing? Financial entry, math function. There we go. Okay. NCR. How do we change the inputs here? No input option. Okay. Well, let's do 3 times 11 choose 10 minus 2 times, and then 6 choose 4. Let's see if it interprets this correctly. Oh man. Okay, that seems good. Sorry, I just want to figure this out because I think that's going to be quite nice if we do this. There we go. And the result is 3. We were correct. Okay, now at least we know how to type this in. We can just use choose. Okay, correct. So we got 3. That is the right answer. Very nice. Okay, let's do the next one as well. So you'll see this is actually pretty straightforward to compute. It's just a pretty new thing that we don't do much of at school. All these factorials and the combinations and permutations things. Okay, next we've got question B. 50 choose 2 plus 2 times 90, choose 1. Okay, so again, if we want to write this out, that's going to be 50 factorial over 2 factorial times 50 minus 2, which is 48 factorial, plus 2 times, and then we've got 90 factorial over 1 factorial times 90 minus 1 factorial. Okay, let's compute this. So 50 factorial is a ridiculously large number. So we can simplify this a little bit by saying this is 2,450 divided by 2, I believe. Good. 2,450, so 1,225, I think, but I'll check this with the calculator just now. 90 factorial over 80 factorial is 90, so 90 times 2 is 180. So this, I believe, gives us 1,405. Okay, let's quickly just check if it's correct, otherwise we'll do the steps on the calculator. So we had 50, choose 2, minus 2, and then 90, choose 1. Okay, let's see what this gives us. $1,045. 1,045, not 1,405. 1,045. Okay, but let's do it step by step on the calculator. So let's actually check. I don't think 50 factorial will actually give us an answer. It's too big for the calculator. Yeah, see, it's ridiculously big number. But let's see what happens. Maybe it can bypass those things if we just put it all in. So 50 factorial. I suppose we can just start with normal. 50 factorial divided by, and then 2 factorial times 48 factorial. That it can give us, yeah, 1125, good. So 1125 plus, and then we've got 2, let's skip the 2 part, let's just do 90 factorial divided by 89 factorial. That's just 90, correct. 90 times 2 is 180. Okay, and then we just add those. So times 2, and then plus 1225. Wait a minute. Oh, it's because this should be a plus. My bad. It is 1405. Yeah. 1405. Correct. Okay, so you see it's pretty straightforward to compute with a calculator. If you had to do this by hand, it'd take a long time. This one you could find some shortcuts to do, but in general, factorials, computing it by hand, it's just long. It's just lots of multiplication. Okay, number C. So here we've got 200, choose 195. So again, we could just use our calculator to compute this, but we could also do it with a factorial way. So 200 factorial over 195 factorial, and then 200 minus 195, which is 5 factorial. Okay, so again, this is going to be a little bit slower to do without a calculator, so let me use one. So I'm going to say 200 factorial divided by, and then 195 factorial times 5 factorial. So it gives us that. Okay. That's a really big thing. Let's see if we get the same thing in Wolfram Alpha, otherwise we might have made a mistake. So we're going to say we want to choose 195 things out of 200. How many ways can we do that? Looks like it's the same answer. 2535 and it ends in 40. 2535 ends in 40. That's correct. Okay. That's it. Let me see. Does my calculator have an NCR function here? No, it doesn't look like yours anyway. I just wanted to show you what it would look like. Let me maybe do this. Let's look for what is the most common Casio calculator. think that's what most people would have these days. Images, something like this. Picture load properly. Okay, so there you see here, that's NCR. That's the button you want to use. So it's a shift and then the divide button, at least on this one. But that's what the NCR button looks like. It just says NCR. Alright, so that was that question A, and then B. Let's finish up with question B. So using the binomial theorem, what is the coefficient of? Okay, so let's start. The thing they give us is a minus 2b to the power 12. And we want the coefficient of a to the power 7, b to the power 5. Okay. So, for this, I'm not sure what method you guys were taught, but I'm going to say binomial theorem basically says that that this whole thing, if we have a plus b to the power n, that's the same thing as saying it's the sum of everything from n equals 1 to n. Let's say from r equals 1 to n of n choose r, and then the first term to the power actually do we say this? Yeah, first term to the power n minus r, and then the second term to the power n. So that is basically the idea here. That's what we do. Okay, so we're going to use this idea, right? So we're going to say the term r plus 1 is equal to, so you don't really have to worry too much about the r plus 1 thing here. The term r plus 1 is equal to, so n choose r of our first term to the power n minus r, and then our second term to the power r. Okay, great. So now we know this. Let's use our actual example here. So in our actual example, we've got n, so n is 12. So 12 r. R we don't know yet. So that's going to be, actually these questions are structured in such a way that we can basically see what r is. But let me show you in case you get the more difficult questions. So we're just going to have r as r for now. Then the first term that we have is also a. So a to the power n minus r. So that's going to be 12 minus r. Then our second term, which is negative 2b to the power r. Okay. So now, like you said, we can see a must be to the power 7. So we can see a must be to the power 7. So that's pretty straightforward there. But let's just show you what the normal way is for more difficult questions. What we'll keep going to do here. So we keep the a's already separated. So we can just leave that as 12 minus r. This we want to separate in case they ask us just for a b something. So we're going to split that up into negative 2 to the power r as well as b to the power r. Okay, great. And now we check what they gave us. We're looking for a to the power 7 and b to the power 5. And in this case, I mean, it just makes exact sense. So a to the power 12 minus r must be a to the power 7. So therefore, 12 minus r must be 7, which means that 12, if we take the r over 12 minus 7 equals r, so 5 equals r, right? So we know r is 5. And we also know that b to the power 5 must be equal to b to the power r. So 5 equals r. So in this case, we could just see it straight off the bat here. But in general, that's what you want to do. If they give you one of these things, you just do that. Put them equal, and then you get what your r is. So now that we know r must be 5, we can plug this in. So we're going to have 12 choose 5, a to the power 12 minus 5, negative 2 to the power 5, and then b to the power 5. Okay, and then we just work out these values. So basically we've got our 12 choose 5, we've got our negative 2 to the power 5, and then we just have our a to the power 7, b to the power 5. So this is what are going to be our coefficient. So to work out what is 12 choose 5, again that's 12 factorial over 5 factorial times 12 minus 5, which is 7 factorial. Okay, so that's going to be our answer there. Let's quickly compute that. So we've got 12 factorial divided by 5 factorial times 7 factorial. Okay, so that's 792. And then negative 2 to the power of 5 is negative 32. A to the power of 7, b to the power of 5. So then we just multiply that, and that's going to be our coefficient. So times that by negative 32, and we get negative 25344. So that is our coefficient for a7b to the power of 5. Okay, great. Let's make a duplicate and just continue some more questions on here, the last couple. So this binomial theorem is actually quite powerful. It's used in a lot of mathematics all over the place. So this is a nice thing. Don't get stressed out if it seems a little bit strange. Let's see, it's really not that bad. Although conceptually it is definitely at a little bit higher level than some of the things we've been doing previously. Okay, so our next one, question B. Here we have negative 2x minus y to the power of 15. And we want the coefficient, or write out the last 3 terms in the expansion. So the last 3 terms. Okay, so that is when this is going to be, when the y is going to be to the power 15 is the last term, y to the power 14 is the second last one, and y to the power 13 is going to be the last one, right? Because we know this starts at 0 and then it goes up to 15 at the end. Alright, so we want these terms. So let's start with y to the power 13th term. Okay, so again, term r plus 1 is going to be n choose r. I'm just writing the formula again. First term to the power r, first term to the power n minus r, second term to the power r. Fantastic. Now let's use our example. So our n is 15, so we've got 15 choose r. Then we've got our first term, which is negative 2x to the power n minus r, so that's 15 minus r. Then we've got our second term, which is negative y to the power r. Okay, again, let's split up our values so we have only our variables, because we're interested in getting this y to the power 13 thing. So let's do negative 2 to the power 15 minus r. Then we've got x to the power 15 minus r. Then we've got negative 1 to the power r, and then we've got y to the power r. So basically you want your x and your y, all your variables by themselves. The rest of the things you want to split up like this. Okay, let's get things by itself again. So 15 over r, 15 choose r. There's negative 2 can come here, 15 minus r, then the negative 1 to the power r, and then we've got our x and our y. So x to the power 15 minus r and y to the power r. Alright, but we know we want y to the power 13, so this must be 13. So r equals 13. Okay, so for r equals 13, let's do this. So now we just make r 13. So 15 choose 13 times negative 2 to the power 15 minus 13, which is 2, times negative 1 to the power 13. And then these ones we don't really care about. That's just, there are no numbers in here. We've already split out all the numbers, so that's just going to be x to the power 2, y to the power 13. So that's fine. So this is the numbers, that's going to be our coefficient. So let's calculate that. So for the 15 choose 13, we can again say 15 factorial over 13 factorial times 15 minus 13, which is 2 factorial. And then we've got negative 2 to the power 2, which is 4. Negative 1 to the power 3, which is negative 1. Okay, and then this again we can work out. So that's going to be 225. Let me just use the calculator. So we've got 15 factorial divided by, and then 13 factorial times 2 factorial, which is just 2, but let me just write the factorial in. So that's 105 times 4 times negative 1. So it's going to be negative, and then 105 times 4 is 420. So negative 420 is our coefficient for the last term. So we actually, the whole term is this whole thing is the term. So let me do this. Let me keep on writing the x squared y to the power 13. x squared y to the power 13. So that's going to be negative 420 x squared y to the power 13. So this is this term. So that's this term, right? The y to the power 13 term. Okay, then let's do y to the power 14. Let's change colors for that one. So y to the power 14. So we're back to this. This thing still remains the same because it's the same thing we expanded here. Now we just have to make r 14. Okay, so then we do 15 choose 14, negative 2 to the power 15 minus 14, which is just 1, and then negative 1 to the power 14. Okay, and then we've got x to the power 15 minus 14, so that's just x, and then y to the power 14. Alright, so 15 choose 14. Let's just do this again. So 15 choose 14. That is 15. Oh, interesting. That's 15. Okay, so this is just 15, and then negative 2, and then negative 1 to the power 14 is positive 1, so that just cancels out. X, y to the power 14, so that gives us negative 30 x, y to the power 14. Okay, so that is our term 14. And then lastly, for term number 15, we just make r equals 15. So then we do 15 choose 15, negative 2 to the power 15 minus 15, so that's to the power 0, and then negative 1 to the power 15. Then x to the power 15 minus 15, so that's 0, and then y to the power 15. Okay, so 15 choose 15 is 1, negative 2 to the power 0 is 1, negative 1 to the power 15 is negative 1, x to the power 0 is 1, and y to the power 15. Okay, so we basically just have, it's a negative y to the power 15. Okay, so that is our 15th term. So those are our last three terms. Okay, that's it. That's it for this lecture. So if you have anything on the binomial theorem that you're unsure of, please write the question there, because I know this can be a little bit daunting and it looks very mathematically. So let me know if there's any troubles there. But basically, if you just this part, especially this part here, you can even just memorize this part and know that n is that, and then r is the thing you want to figure out. So once you've simplified this out up to this point, right, getting all the numbers out from the variables, then you check, what do we want? We want, maybe they ask us, what is the coefficient? Let's do one more question. What is the coefficient for the term with x to the power 7 in this expansion? Okay, so once we get to this spot here, now we just say x to the power 7. Okay, so that's the exponent for x. So 15 minus r must be equal to 7, which means that r equals 8. So all we do is replace r with 8 here, and then we find the coefficient. So we'll do 15, choose r, so r is 8. Negative 2 to the power 15 minus 8, which is 7. And then negative 1 to the power r is 8. And that's going to be your coefficient. Then you just calculate this. That's your coefficient for the term where x to the power 7 is. Alright, I'll stop the video here.